So we are at chapter 5. So we are going to see the introduction to lambda expression in this particular chapter. So this chapter will teach us how we are going to write lambda expression in a syntactic perspective. The functional part means what the real usage of lambda expression we will be seeing at later point of time. So let's get started. So in the previous chapters we talked about these inner classes, particularly this anonymous inner class. So I will start with that. So first I'm going to create an interface. So my interface name is travel, and in this particular interface we are going to have a abstract method. So my abstract method is going to be like get speed, and say this get speed currently doesn't have any parameter. Now let's write an implementation for this particular travel. My class name would be travel impl implements travel, and let's implement this particular method. So this is a normal way how you are going to implement an interface. But we can also implement the interface using anonymous inner classes. So I'm going to delete this and let us do it with anonymous inner class. So travel impl. Let's create an anonymous inner class for this particular travel. So we talked about anonymous inner classes and then how things are going to work previously. So I'm not going to explain about anonymous inner classes now. The previous chapters we already talked about it. So let's directly jump on to lambda expressions. The first thing what we should know about lambda expression is, so lambda expressions are, let me write it, lambda expressions are implementations for functional interfaces. So we already talked about functional interfaces. So if an interface has one abstract method, then we can annotate that particular interface as functional interface. So any functional interface is a single abstract method interface. It will have only one abstract method. So I can write a functional interface annotation here. So lambda expressions are written for an interface which is having a single abstract method in it. So if I have an interface which is having single abstract method, I can write an implementation to that particular interface using lambda expression. So let's try to write it for our travel interface. So I have wrote the implementation as anonymous inner class in this highlighted section. The same thing, let's try to write it as a lambda expression. The left hand side retains same, and in the right hand side how the syntactical part is going to work, we need to define the method for capturing the parameters. So there is no need to define the access modifiers like a public, private or protected, and the return type we don't want to declare, method name we don't want to declare, just open and close brace and capture the variables. Currently our method, our abstract method doesn't have any parameter, so it's an empty open and close brace. Then you put the lambda symbol. So this is your lambda symbol which we are going to put dash and greater than, that's going to be our lambda symbol. Don't have a space in between it, it should be like next characters, and then start writing the implementation. So our current implementation requires to return an int, so I'm going to return some value. So this also I will change it to 100. So I'm going to return a value. Now this thing got compiled and everything is fine. So what is actually happening is like how to understand a lambda expression. Look at the right hand side, and this is divided into two parts, your lambda expression left hand side and your lambda expression right hand side. Lambda expression left hand side will have the arguments to your underlying method. There will not be any method name or return type or any modifiers, public, private, protected. Of course there is no need to have modifiers. The reason why is any abstract method which is declared inside an interface is always going to be public, so no need to define that. So you just have this particular symbol to capture your variables, and then lambda symbol, and write your implementation. So if your implementation is going to be a single line, then there is no need to define a return keyword. If your implementation is going to be in multiple line, so I'm going to write a multiple line now. You are there, we need to have the return keyword. right? So see the syntax how we are going to do it for the multiple line, and we need to put a semicolon here in order to make sure things are going to be compiled. Let me change the variable to lambda travel 1. So this is how we are syntactically we are going to write lambda expression. The real advantage of doing lambda expression we will be seeing in subsequent chapters. There is a concept called behavior parameterization which we need to know. So that in that chapter only we will really understand what why we write for lambda expression and how it will help us to do functional style programming in Java, right? So syntactical perspective, this is how the lambda expression is written. Let's go and change our interface to have a parameter. So let me introduce a parameter here. So we are having two parameters now. First parameter is an int parameter and second parameter is a string parameter, and we need to change correspondingly here. And now what happens? So we are going to capture these two parameters in the lambda expression, something like this. And we will be able to use these variables as well for our implementation. So now this speed and this model is a local variable for this lambda implementation, and we'll be able to use those local variables. Another thing what we should understand is like there is no need to declare these types here. So if I'm going to remove the types also, this should work. So I have completely removed the types now, and it should work. There is no compilation error which is coming up. I'll put the same for the next lambda expression also. So there is no compilation error which is going to come up, and they should work. So how compiler finds the type of this speed and model? It will infer the types from your underlying interface. So every lambda expression is targeted for an interface, right? From the interface, it can find out your abstract method and then what is the parameter to that particular abstract method. So that's how your compiler is going to find those types. So you will be able to use these types. So typically a lambda expression will look like this. Mostly it will be single line implementation, and your parameters will not have any types, and you will be writing an implementation in a single line. Typically a lambda expression will look like this. In any real application, if you see the usage of lambda expression, you will be seeing syntax like this. So again, when you see a lambda expression, so how you are going to understand? Left hand side to lambda is going to be your method parameters, what you are going to define, and right hand side to your lambda is going to be your implementation. And this entire lambda expression is targeted for an interface, for a functional interface. So interface which is having single abstract method is called as a functional interface, and it is targeted to your underlying functional interface. So this is all about the basics of writing a lambda expression. The next chapters we will talk about effective, final and invoke dynamic. That's the other important thing what we should learn about, which will give you more perspective on lambda expression. Thank you.